Hey everyone, in today's video we're going to be talking about linear equations still, but we're going to be learning a new notation for writing and talking about equations. So the old way, the way we've been using so far, is to write equations like this. So y equals 2x plus 7. And this equation happens to be in our slope-intercept form. But the new way is going to look a little bit different. So I'm going to use some colors here. And this is how it's going to look. Okay, so now it's going to look something like this. So it's going to say, we read this as f of x, so I'm going to put down here f of x, and then obviously would say equals 2x plus 7. So this new part is the f of x. And so here's what this notation means. This f here is just the name of our function. So we're just happening to call this function f. The x is still our input, just like it was before. If you think of when we make our x, y tables, right? The x is just always our input. And then the 2x plus 7 is the function itself. And this is what gives us the output. So if you think when we were graphing by using a table, right, we would take an x value, we would plug it into that function, and it would give us the output of the function. So our new notation is this function notation, this f of x. Okay, so function notation is a different way of writing an equation, and it allows us to see both the x and the y value for a function at the same time. And we'll talk a little bit more about that in a little bit here. Now, we can still substitute x values and solve equations in function notation. Okay, so here's what this is going to look like. We have a problem here. This is kind of what we did before. So our equation would say, suppose y equals 3x minus 8. That was our equation. And our directions told us to find y when x equals negative 3. So remember, we would take our equation y equals, and we'd copy everything down, but we kind of left a place for that x. And then we said, well, x is negative 3, and we substituted that for the x in our equation. So now when I simplify, we got 3 times a negative 3 was a negative 9. Negative 9 minus 8 is a negative 17. So the value of y when x is negative 3 was negative 17. Now the problems are going to look a little bit different. Now it's going to say if f of x equals 3x minus 8, so still the same equation, but now we have our function notation. Now it's going to ask us find f of negative 3. Again, all this is telling me is that wherever I had x in my equation before, now I'm going to substitute a negative 3. So I'm going to make a note here. So f of negative 3 is now 3 times something minus 8, but that something here, this negative 3, just gets substituted in for that x value. Wherever I had x before, now I'm replacing it with a negative 3. So again, it'd be negative 9 minus 8 is a negative 17. So we would say f of negative 3 equals negative 17. So here's what we mean up top when we are saying it allows us to see both the x and the y value. Here I can see, well, when x was negative 3, my y is negative 17. So I can see both the input and the output at the same time. That's not as clear when we have this kind of notation over here. Okay, So let's look at another one, and I'm going to adjust the camera here. Okay, so now it says what we did before. Suppose y equals 3x minus 8. Find x when y is 10. Now we have to be a little bit careful here. They've switched the directions. So now they're telling us what y is equal to. So now I have 10, right? I'm substituting the 10 for the y, equals 3x minus 8. And here's where we need to kind of revisit those skills on solving equations, right? Now my goal is to get x by itself. So I'm going to draw my line. I know to get x by itself, I have to move this 8. So I'm going to add 8 to both sides. I get 3x is equal to 18. Now I'm going to divide by 3 on both sides. That's going to help me get x by itself. And I know x is equal to 6. Now, in our new world here with function notation, again, it's the same idea, just the notation is different. Now it says if f of x equals 3x minus 8, find the value of x so that f of x is equal to 10. So in other words, I'm still just substituting instead of f of x, I'm replacing it with 10. So I've substituted 10 for f of x, and then I'm going to go ahead and solve my equation. And again, it's the same equation. So I'm going to use the same steps to solve. Last step is to divide by 3, and x is equal to 6. So again, I just want to keep reinforcing here, the only thing that has changed is the notation. Really, what we used to call y has become f of x. All right, let's take a look on the next page. Let me get set up here. Okay, so now we have a new notation, or excuse me, a new problem. Our function is f. So now f of x equals 3x minus 15, and we're going to use that equation to calculate all these following answers. So the first one is we're trying to find f of negative 3. So instead of x, wherever I see x, that's now going to become negative 3. So I'm going to say, I'm going to copy this here, f of negative 3 equals 3, and again, I'm replacing that x with the negative 3, and then minus 15. So again, I copied everything in the equation except I substituted negative 3 for that x. Now, this is just going to stay f of negative 3. I'm not doing anything with that side. That's just the name of the function. All I'm doing is simplifying the right side. So 3 times a negative 3 is negative 9 minus 15 gives me a negative 24. So I know that f of negative 3 equals negative 24. And that would be my answer. Again, this is just the name of the function. Okay, so for number 2, if I wanted to find f of 4, again, I go back to my original equation. Wherever I see an x, I'm going to replace it with the 4. So now f of 4 is going to be equal to 3 times, instead of x, sorry, I'm swapping the pens out here, I'm going to put in a 4, and then I'm going to do minus 15. And again, f of 4 is just the name of the function. So all I'm doing is working with the right side. I have 12 minus 15, and that's going to give me a negative 3. So f of 4 is equal to negative 3. Now, number 3 is a little bit different. This is asking me to find the value of x such that f of x is equal to 30. Now I'm substituting for f of x. So here I know f of x is equal to 30, and that's equal to 3x minus 15. So now I'm back to needing to solve here. So I'm going to add 15, use that inverse operation. 3x is left on this side. On my other side I have 45. To get x all by itself, I'm going to divide by 3, and so I know x is equal to 15. All right, and for the last one again, this is one where we're substituting the value of f of x. So f of x I know is negative 24, and I know that's equal to my 3x minus 15. And again, we're going to solve one last time here. So adding 15 to both sides, I'm left with 3x. Now negative 24 plus 15 is going to give me a negative 9. To get x by itself, I'm going to divide by 3. And so x is equal to negative 3. Okay, so that's a quick overview of function notation, and then obviously when we're back in class we'll do some practice with this. All right, have a great night, and I'll see you back in class. Thanks.